This is part 2 of my series on peak particle velocity monitoring for geophysical operations. This is on sensor deployment, and while it's under geophysical operations, it pretty much applies to all applications. The reason I made this video is I've seen lots of deployments where the sensor is just put on tall grass or undulating ground and the recording starts. So this is the way I do it. Any comments or suggestions for improvements would be appreciated. Thank you. Okay, so this is basically what I carry for doing a setup with the Instantel sensor. So I carry levels. I normally have a 2-axis level, but I had to give mine away to a crew the other day that had no levels on site. I've got some of the shorter spikes, a little bit longer spikes, and then I've got some spikes that are adapted and made so I can adjust them if I'm in really loose material or muskeg or something like that, and even longer ones if I need to get more coupling or whatever because of how soft the material is. I carry Teflon tape. You will see there's Teflon tape on this one, and I'll explain that a little bit later. Here is the sensor. It's currently upside down. These are where the spikes go. If I'm going to just try to set it on the ground like this and I'm moving it around, I could end up, if it's a little mucky, getting stuff inside the threads. That becomes problematic to clean. So in this case here, I could try to get this. That's fairly level like this in that axis, and quite level like that in this. But often you're not going to be able to find this, and you're going to have to be using spikes to get it level, and you want to have good coupling. While this this ground is generally kind of undisturbed, it still is kind of backyard soil, so you can see there would not be good coupling, and you'd want to use spikes for something like that. So let's get to that. Okay, so I've outfitted this with the longer spikes here. I'm going to aim the longitudinal axis at my energy source, and we'll put it in. And you'll see that kind of went straight down or whatever. It's going to have better coupling. I can still wiggle it. I can work on getting it leveler. But you can see now I'm going to have to start removing some material to get it level there. So that's a bit problematic. Also, if you're going to be in close proximity to the energy source where you're going to hit 0.2 G or higher, then you're going to want to make sure you are spiked, and you probably want to sandbag. So with us, depending on what size of explosives you're using for geophysical or vibrators, but with a vibrator it might be as far as 20 meters away and you might be achieving 0.2 G, so you'd want to sandbag this as well for good coupling. But now let's have a look at what you're supposed to do in these type of ground conditions. Okay, and before I do the big reveal here, these are some of the other tools that I carry with me. Shovels, small little landscaping shovel, a little chisel, wire brush, just to clean out the material later on to make sure I've got good coupling. So there's that. So let's look at the kind of the location. This is typically what I do. And you can see still lots of loose material in there. So I want to get to where I get good coupling and lots of little roots. So there's some more work to do to this. Now we're getting down to some clay here. In this case, need to remove some of this material. Don't want it blowing in the wind and actually hitting our sensor cable. Not sure if you can see straight down there, but I'm much more on clay with everything. and we're going to have much better coupling. But again, it's hard to get a good level surface because your perception is quite a bit different from an angle here. But I'm down about, I'd say close to a foot, and they recommend going at least 2 times higher than the sensor, which is about 1 3/4 inches, so let's say 2 inches. So you're supposed to go down at least 4 inches to 6 inches, but in this case I'm down a foot with the sensor. Again, working on the alignment. I'm going to try to make sure this cable isn't going to bang onto anything, and I'm going to start putting it in. And I'm in much firmer clay now, so I got much better coupling. Wearing my good impact proof, cut proof gloves. We'll get the level on there, single axis level, but we'll level it in both directions, being careful to push steadily and not have it rocking back and forth. Line it up on the other side. Get it coupled and check that side, and that would be awesome. So now at this point I would have it hooked up to my sensor, and I would do a sensor check to make sure everything was good. Now if I was expecting large vibrations, if I was in close proximity where I was going to get greater than 0.2 G, maybe a bit more, then this is where sandbagging the unit comes in, and it's mentioned in the ISEE seismograph guidelines. So I would put this on top of the sensor, make sure it's fully covered the sensor like that. Now because I've done that, I would now run another sensor check and make sure that I have not disturbed the instrument, and that would be that. As the sensor check was going on, I would probably be using a rangefinder. I'd be at this location, and let's say I was close to some structures, then I would try to triangulate with my rangefinder and maybe take a distance back to, let's say, the front door of the house. And then there's a post on the other side of the road at 120 degrees kind of offset in there, and then I would triangulate the other direction, so I would get 3 distances back to my location. I would probably also use an Avenza map or just use Google GPS to get a fix. Now those Google and GPS handheld stuff is only going to be plus or minus 5 meters, but it gives me a good gist as to where I am. It's the triangulation that's kind of quite important. Okay, so I would be doing my readings, monitoring. Of course, I'm supposed to be aimed at the energy source, and in part 2 of this video I'm going to talk about the orientation and how important that is, because with this setup, if my vibrator or dynamite shot was now offset at 25 degrees from which way I'm aimed, it would take a fair bit of time to undo the sandbag, turn this, realign it, redo a test sensor check, put the sandbag back on, redo another sensor check, and go into the monitoring mode. So, you know, that becomes a very important aspect. So I've recorded a bunch of events, documented them, time, offset distance, readings, and then I'm done. So I stop the sensor, and then I do another sensor check before I do anything else. And then I just document that on my field notes that I did a pre-sensor check and a post-sensor check, and mark the results, which I'm going to assume is a pass. But that's what I do. So now it's time to put this location to bed. Come in here, remove the sensor, And yes, from time to okay, and of course the battery went dead, so we have to get back at this. So it's time to put the location to bed. One of the things I didn't mention is from time to time I might use some of the sand to help with the leveling from the sandbag for the location. So now you've got to put this back to bed, particularly let's say you're on a landowner's piece of property or some common shared ground. So you'll want to be able to put this back to bed in a reasonable way. You know, with some sods it's much nicer, but I think you get the gist of what I'm doing here. One of the other things I would do here is I would take a steel washer and I will put it here at the location. And that way, if I had to come back and say, hey, this is where I set up, I would be able to do that, and there would be that washer there. I might use a dab of paint if I'm set up near a highway or a road, and just have a little bit of dab of paint there, spray paint, and say what my offset was. If, for example, this was a very good solid location, good firm soil, and I didn't dig a hole, I would probably take the washer like that, just go like that, just place it in the soil, and I'd be able to find it with a metal detector, come back to the location and say, yes, this is where I was set up, particularly if I had not dug a hole. Okay, and that's it for that component. Okay, so here we're kind of set up on some asphalt, so this would be considered really hard ground, and you'd like to get your instrument level. So I put the shorter legs on it because I am going to have to sandbag this location, so I don't want it standing up really tall, so I've got the shorter legs on it. Now Instantel sell a leveling plate that is a very high-end product. It's great. Got some very fine threads for doing this. Now earlier I'd mentioned the Teflon tape on the threads. I do that so if I turn the threads a little bit, I still have good coupling. So what I do in a case like this where it's not level on this axis or this axis, I move it around and try to get it as best I can. But let's say this is the location. Now I can see that the front has to come up here, and because it's not level and it's aiming down, that means the vertical one is also not level. So if you're out in this direction, in the longitudinal axis, the vertical will be out. If you're out in the transverse axis, the vertical will also be out. So when it's doing the pulse test, if it's unlevel, you are not going to get a pass result. So basically what I do is it's pretty much like a survey instrument that's on a tri-brack. So because I have the three legs, I can actually turn this threads just a little bit here, and you will see that has started to level it. And I do go about halfway, 2/3 of the way, because I know I also have to do this one as well. So I will do that. Now I generally don't like to turn these too much, like half a turn, just to get it level. So then I check the other axis, and by doing that, this has to come up just a little bit, and I'm just turning it a wee bit. And then with their with the tri-brack, it's a little bit finer, but this is essentially how you would do a survey instrument. So that would be level. I would hook it up to my instrument. I would do a sensor check. Then I would come and I would put the sandbag on it to get it good and secure. A good big sandbag that will drape on all sides, touching the ground. I would do another sensor check, and then that's how I would leave it. The tri-brack is, the Instantel tri-brack is a great piece of kit for doing something like this. But if you don't have one and you're stuck, then you could do this. But do put Teflon tape on the threads so you do have that little bit better coupling, because as soon as you start to undo it a little bit, it's not as good. So the last part of this video is just to introduce what I'm going to talk about in the next video, which is what happens if my longitudinal or transverse axes aren't aimed at my energy source, which happens often with, for example, a vibrator source on a geophysical program that's constantly approaching. You don't have time to reorient the sensor every time. So if you look at this last slide, in the image in the top left-hand corner, imagine a perfect 10 millimeter per second strike on the longitudinal axis. You would record 0 in the transverse, 0 in the vertical, and 10 millimeters per second in the longitudinal. In the second image in the middle, if you had a perfect 10 millimeter per second impact on the transverse axis, you would measure 10 millimeters per second on the transverse, 0 on the vertical, and 0 on the longitudinal axis. Now, what happens if you impact your sensor at 45 degrees offset from the longitudinal and the transverse axis with that same 10 millimeters per second? Well, you're actually going to get a reading of 7.07 millimeters per second on the transverse and 7.07 on the longitudinal. And so you are not going to actually measure that 10 millimeters per second because you are not aimed at it. And that's what we're going to discuss in the next video. Thanks.